morning class. Today we will be studying how to find the MGF of a normal distribution. Uh, so as we all know, we all by now know what is the PDF of a normal distribution, and we have studied the properties of MGF. So using both of them, we shall see how we go about getting the MGF of a normal distribution. So as we all know, we shall first state what is the PDF. So if x follows normal between mu and variance sigma square, then we know that its PDF fx is given by 1 upon sigma root 2 pi e raised to minus 1 half x minus mu upon sigma the whole square, and most importantly, we should know the range of these random variable x and the parameters mu and sigma. X is from minus infinity to plus infinity. Mu, the parameter, is from minus infinity to plus infinity. And sigma, the variance, is always greater than 0. Sigma standard deviation, the square of it is a variance, is always greater than 0. So this is the PDF, we know about it. Now we also know the properties of MGF. MGF means moment derivative function. So the MGF for any distribution is defined as mxt is equal to expectation of e raised to tx. This is the way we define MGF, we know about it. So here we are talking about a continuous distribution. So when I am talking about expectation of e raised to tx, this should be equal to the range of x, whatever is the range of x, e raised to tx, fx, dx. This is the way we would define the MGF for a continuous distribution. Here we are talking about the normal distribution, and therefore MGF or MXT is given by integration. What is the range of x for us over here? It's from minus infinity to plus infinity. So integration from minus infinity to plus infinity, e raised to tx, f of x. F of x is the PDF. What is the PDF? We have written the PDF, so we take it down here. It's 1 upon sigma root 2 pi e raised to minus 1 half x minus mu upon sigma the whole square dx. So this is the way the MGF, we are going to start off with this coordinate and we are going to derive it down to a particular formula which we will be using always whenever we are talking about the MGF of a distribution. Now over here 1 upon sigma root 2 pi is a constant. It can come outside the integral and we will be left with the remaining things. So what are we left with? If I push this 1 upon sigma root 2 pi outside the integral, then my next step, I'm going to do it here itself. My next step would be this is equal to 1 upon sigma root 2 pi. It is a constant, it comes outside the integral and I'm left with these things. Now over here I see that I have x minus mu upon sigma the whole square. I have a huge number around it. Let me bring about a transformation. Let me say let x minus mu upon sigma be equal to z. I'm going to call this term that I have as the power of e. That is the power of e over here. I'm going to call it as some z. I'm going to bring about a transformation. If this is so, then x can be written as mu plus sigma z. Now we know that x is a value between minus infinity to plus infinity. So whenever x takes the value minus infinity, z will also be minus infinity. Whenever x takes the value plus infinity, z will also be plus infinity, and therefore the range of x, when I am taking the transformation that x minus sigma is equal to z, I see that the range of z is also between minus infinity to plus infinity. X can be written as this, and when I take the differentiation of this, I get dx is equal to sigma dz, because the variable over here is z. Mu is a constant out here. When I'm trying to bring about this time. And so I'm going to plug into this equation that we had with this. Into this equation, I'm going to plug in these values. So wherever I have an x minus mu upon sigma, I'm going to replace it with a z. Wherever I have an x, I'm going to replace it with mu plus sigma z. And wherever I have a dx, I'm going to replace it with sigma dz. I hope that's fine with everyone of us. So I will just erase what I wrote at the top so that we know when I input these values how do they look like. So this brings about a linear transformation. Therefore, my mxt, when I'm calling x minus mu upon sigma as z, it would turn out to be 1 upon sigma root of 2 pi. The integral, the value of the integral is from minus infinity to plus infinity for z. So I keep it as minus infinity to plus infinity. Instead of e raised to tx, I'm going to change my x as mu plus sigma z. So it's going to be e raised to t mu plus sigma z. And into e raised to, this entire thing is going to become a z. So it's going to be again write as minus z squared by 2. And instead of dx, I'm going to write it as sigma dz. I hope everyone is fine with this. So this was the original MX, the MGF. Here we substituted the fx value. We brought about the transformation. So instead of having x now, I'm going to have things in terms of z. And this is what happens. So with your permission, I'm going to erase this off, because whatever we have done here is projected out here. And now let me look at things clearly. I have e raised to tx, e raised to t mu plus sigma z. In that this mu and t are constants. The variable out here is z. It is z that is moving from minus infinity to plus infinity. I can take that outside the integral. Also, I have a sigma here and I have a sigma here. They will be cancelled. So what are I left with? I am left with, I can say this becomes e raised to mu t upon square root of 2 sigma integration minus infinity to plus infinity e raised to t sigma z. The base is same, the base is e, so the powers can get added. That's a minus sign here, so it's going to be minus z squared by 2 dz. And this can be further simplified as I can write this as e raised to mu t upon square root of 2 pi. We know that whenever in statistics we are dealing with the e raised to something, we would always try to have e raised to minus terms. We will keep e raised to minus, I will take this minus 1 upon 2 constant outside, and e raised to minus 1 upon 2. And what remains inside, it will be z squared minus 2 t sigma z. I hope the equation holds, the quality holds out here. What have we done? We have taken minus half constant outside, and so this is the transformation that will happen in this equation. Now, let us concentrate on this term that we have over here. I can look upon this term, whatever I have over here. This is z squared minus 2t sigma z, and can consider this to be the first and the second term of an expansion, which is z minus t sigma the whole square. So if I have z minus t sigma the whole square, let's expand it. What are we going to get out of it? So this is going to be equal to z square minus 2 sigma t, 2z sigma t plus t square sigma square. So what I have over here are these two terms, right? So I can replace this. I can Z minus E sigma the whole square minus E square sigma square. I hope you all are understood it. This happens to be the first term and the middle term of this, what do you call it? If I expand the Z minus E sigma the whole square and expand it, I will get it registered. And the first and second term is same as what I have over here. So I can write this as e raised to ut upon